All right, let's see how you did on your interpretations. I had you pause and try these on your own, so let's see how you did. All right, so this was see how they wrote this interval, and you might be exposed to the interval being written this way. Okay, so I wanted that to be there. So we have 95% confident that the proportion of all orders that arrive on time is between 82% and 94%. All right, so let's see what we have. So, a lot of times I like to kind of think in my head, even if you don't write it down, I like to think in my head what the correct interpretation is. All right, so does this mean that between 82 and 94% of all orders arrive on time? If not, what's wrong with that statement? So, I would say that that is kind of like too secure or too confident. I mean, it's kind of like saying this is what is definitely going to happen. If they had started with, then if I'm 95% confident that, and then did that statement, it'd be correct. Okay, it's kind of too sure about that. All right, the next one. Does this mean that 95% of all the random samples of customers will show this amount? Oh, it should have been 82 to 94% of orders. So that was a typo, but that wasn't what made it wrong. So this was about other people's samples being in my interval. Okay. And that could be wrong because I could have an outlier interval. All right. They're not about containing other sample results. All right. How about this one? Let's see. Does this mean that we are 95% confident, 95% sure, liking this so far, that between 82% and 94% of the orders placed by customers, they ruined it in this sample. So they're just talking about that sample I got. Well, I'm pretty sure the proportion in that sample was 88%. Okay, that's how I got that interval to begin with. So by putting in this sample, that was what made this wrong because it's about 82 to 94% of all orders. I'm 95% confident that between this and this of all orders placed will arrive on time. Okay. All right, next is this one. Does this mean that 95% of the days, so 95% of the time, this is going to be the proportion of orders that arrive on time? If not, what's wrong with the statement? Okay. Well, hopefully you can tell this is saying 95% of the time, the true proportion will be in my interval, and the other 5% of the time, the true proportion will be somewhere else. So that's implying that that true proportion or that true population parameter is moving around. It's sometimes this and sometimes that. And that's not the case. It's a set value. Okay, so that's all of those. Let's check the next ones. All right, here is this. We are talking about let's see. The proportion, in 2002, headlines were made because they spun the Belgian euro 250 times and 140 heads. That's 56%. So does that mean that the 90% confidence interval was 51 to 61%? Okay. Interesting. So, is this evidence that it's not fair? Okay. Well, here we go. Does this mean that if you spun the euro many times, you can be 90% confident of getting between 51% and 61% heads? If not, what's wrong with that statement? So that sounds to me like if you take another sample, you can be 90% confident that your sample is going to be in my interval. That's a no-no. Our interval is about containing the true population. It's not about, another sample spinning it many times being in my interval. Okay, what's next? Does this mean that we are 90% confident that spun Belgian euros will land heads between 51 and 61% of the time? I'm kind of liking that one. I left it blank. I guess that, yeah, I'm 90. That's kind of what I'm saying is I'm 90% confident that the true proportion of times that the spun euros will land on heads is between 51 and 61% of the time. That's what my interval says. Okay, moving on. Does this mean that we are 90% confident that in this experiment, eh, that's talking about the results I got? Well, excuse me, the results I got were what, 56%? So, anyway, so that's what made this wrong. It's talking about my p hat. So, all right. So, of course, it's in my interval because that's how I created it. Does this mean that 51% to 61% of all Belgian euros are in fair, if not what's wrong? So that's kind of like too certain. I'm missing the, oh, look what I didn't, why did I not do all my answers? So this one is missing the 90 whatever percent confident. Okay. It's too sure. Okay. It's saying it is going to be that way. All right, so now let's see what's going on here. So several factors are going into creating a confidence interval. I think what I'll do is I'll do this problem on the next notes because it's about different sizes of margin of errors, okay? So I'm going to leave this problem for the next one. And I think you've got the idea. If you still want some more examples, then we had this one in our Hershey's Kisses lab. And so I went ahead and I put all the answers in here. And so you can take a look at those if you want to, but I think we've kind of run this examples quite a bit. And so I want to go ahead and stop at that point. All right. I will see you in the next video where we'll talk about some more things about specific margin of error sizes and make sure that we've got that mathematical relationship correct.